Welcome back everyone. We're back to our series on SURDS. So in the previous lessons we've learnt what SURDS are and how to tell what's a SURD and what's not. So in this lesson we're going to be working on how to simplify SURDS, so to put them in an easier way for us to understand and work with. Now all the SURDS that we've been working with so far have been in a pretty nice easy form, so they've been in something like this, which is pretty easy to work with, or we've also seen them in, a form like this, where we've got our number out the front and we've also got our SURD right there. So what if we have a really ugly number? So say for example we have 1800 and we don't really want to have to work with such an ugly big number. What can we do to simplify this? So before we learn how to simplify these big numbers, we first need to learn a couple of SURD rules in order for us to do this. So our rule number one is this. So for any number that's bigger than 0, and we're going to call that number x here, the square root, so remember that a square root is short for writing it like this with the 2 out in front. If we had a cube root, we'd put a 3. So if we have a square root that is squared or put to the power of 2, the answer is that same number, x. So what does this mean? So the first thing that we have to remember is that squared, which it means any number times itself. So let's call this number x again. So x times x is the same as x squared. That's what we got to remember. And if we look at it in this case, our x is actually root x. So in this case here, root x times root x is the same as this root x squared, which, as we know over here, is x. Okay, so a square root and a number squared are opposites. Okay, so let's keep that in mind. So remember they're opposites because our square root is asking which number when times by itself equals the number in here, whereas a squared number is just simply asking what is a number times itself. So notice that they're the opposite of each other. So just to make sure that you get the idea of this, let's take a few other opposites that we know, for example. So let's take 9 plus 2 minus 2. Now we should know that this plus and minus are also opposites. So what happens here is that these two cancel out and we simply get a 9. If we were to take another opposite that we know, let's just say 9 divided by 2 times 2, which is the same thing as 9 times 2 divided by 2, you get the same answer. These two here cross out again because a divide and a times are opposite. So by the same logic, if we have a square root of a number and then a square of a number, what do we think is going to happen? They're going to cancel out. So if we use our same numbers there, if we use 9 root 2, so a square root of 9, and a square, then these two things here are going to cancel out and we are simply going to get 9. So if you don't believe me, you can always go through and do it by hand. So if we take our square root of 9 first, we know that this is 3 because 3 times 3, those two numbers, equal 9. And then if we want to take this 3 and square it, what do we get? We get 9, which is the same number that we started off with in this form in the beginning. So it is true. So that is our rule 1. Okay, so now onto our rule 2. Now this one, again, we're going to take two numbers this time that are bigger than 0. So we're going to call these numbers this time x and y. And this rule states that if we have a number inside the brackets that can be split into two factors, x and y, then we can take these factors separately into their own roots and it will still be the same thing. Now this rule here, rule 2, is probably the most effective in simplifying those big ugly SURDs that we saw at the beginning. So just to show you what I mean here, let's go back to our example of root 1800. So what this rule says is if this 1800 can be split up into smaller factors, then it will be the same thing. So the trick is here to make this in the easiest form possible for us is that we want to split this 1800 into little parts, but we want to try and find parts that are square numbers. So think of some square numbers like 1, 4, 9, 16, 25, 36. I'm sure you could go on. So just what these numbers are is this 1 is 1 squared, this is 2 squared, this is 3 squared. So you could keep going on there. So the reason why we want to try and pull out a square number, let's just say we pull out something like we can pull out root 25, then we can write this again as 5. That'll make it a lot easier for us later. So anyway, going back to this example of 1800. So straight away, because I can see these 2 zeros on the end, I know that I can pull out a factor of 100. So I can rewrite this as root 18 times root 100. Now, this is just simply 18 times 100 will give you this number here. So we're just using that same rule up there. Now, looking at this 100, I should be able to tell that this is the same thing as writing 18 times 10 because root 100, put in your calculator, it's the same thing as. Now let's look at this next one, which is 18. So we can still keep going. And I know just by looking at that straight away that this can be split into root 9 times root 2. And remember to add on your 10 on the end. Now, do any of these, can they be simplified further? So this root 9 looks familiar, doesn't it? So what this root 9 is it's the same thing as 3 because 3 times 3 equals 9. So we can go 3 times root 2 times 10. That's looking a lot better now and will be easy for us to work with. Now, once we have it in this form, so we've got our whole numbers and our SURDS. So this is a SURD, which means we can't simplify it down anymore. Then what we're going to do is we're going to group together our whole numbers and any different SURDS that we have. So if we had, let's just say we had a times root 3 here, these two we would group together as well. So let's get rid of that for now. We don't need that. So in this case, we can go 3 times 10, group that together, and then out times root 2. So 3 times 10 then we can do separately. Now that's going to be 30. And then with this root 2, we just write it like this. So it's 30 root 2, which is simply short for 30 times root 2. So that answer there is now simplified into its easiest form for us to work with. Okay, so hopefully those 2 rules make sense. You're going to need those 2 rules in the next video, which we're going to do, which is going to be looking at a few examples from the textbook in simplifying these SURDS. So hopefully I'll see you in the next video.